So let's talk about graphical representation of a linear function. All right, inside this word linear, you should see the word line. All right, so this unit is all going to be dealing with linear functions, and the graph of them look like lines. Okay, so a couple key things to remember. We've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, in quadrant 1, the x-coordinate is positive, the y-coordinate's positive. Quadrant 2, the x-coordinate's negative, the y-coordinate's positive. Okay, in quadrant 3, both coordinates are negative. And in quadrant 4, the x-coordinate's positive, the y-coordinate's negative. All right, and a couple new ideas. We have a point here, which is called the x-intercept. And we have a point here. This is called the y-intercept. All right, it's the x-intercept because it's where it crosses the x-axis. All right, x-intercept, it's where, so I'll say the full x-intercept is where the function crosses the x-axis. It will have the coordinates x, comma, 0. X will be some number, and the y-coordinate will be 0 on the x-axis. All right, the y-intercept, same idea. The y-intercept is where the function crosses the y-axis. The x-coordinate is going to be 0, and the y-coordinate is going to be some number. Okay? Remember, we got our x-axis and our y-axis here on the coordinate plane. So x-intercept and y-intercept is going to be an important concept moving forward, not only in linear functions, okay, but also in future functions that we deal with. So, graphing linear equations using tables. So this is going to be the first way we graph. All right, we're going to plug in numbers for x, get out numbers for y. All right, that's going to give us coordinates x, comma, y. We're going to plot those points, connect the dots, and then be good to go. We got our line. So we got y equals negative 2x plus 5. I'm going to start by plugging in 0 for x in my middle column. All right, so y equals negative 2, and instead of x, I'm going to plug in 0 plus 5. Negative 2 times 0 is 0, so that cancels out. 0 plus 5 is 5. Okay, so I get 0, 5. Next up, I'm going to plug in some points below and above 0. So if I plug in 1, I get y equals negative 2 times 1 plus 5. Well, negative 2 plus 5 is 3. Excuse me. If I plug in 2, y equals negative 2 times 2 plus 5. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. All right, now on below 0, if I plug in negative 1, I'll get negative 2 times negative 1, which is 2. 2 plus 5, which is 7. Then if I plug in negative 2 for x, negative 2 times negative 2 is 4. 4 plus 5 is 9. Okay, so I am going to plot all of these points. I'm going to plot negative 2, 9, negative 1, 7, 0, 5, 1, 3, and 2, 1. So negative 2, 9, 2 to the left, up 9. Negative 1, 7, 1 to the left, up 7. 0, 5, I'm just going to go up 5. 1, 3, 2, 1. Okay, and then I'm going to connect these dots with a straight line. All right, I plotted the points. That's the graph of this linear function. Now I want to label the intercepts. Okay, here's the y-intercept. And that's a nice point, 0, 5. And here is the x-intercept, which is about, we could say, 2.40. And this right here is an approximate answer. We don't actually know what that x-intercept is, okay, but we know it's between 2 and 3, so 2.4, about. Okay, but those are the intercepts. What about in B? So I'm going to plug in -2, -1, 0, 1, and 2. I'm going to plug each of these in, all right? So I want you to pause the video right now, and I want you to see, what do you get out after plugging in these values? Pause the video and try. Okay, so you should get -13, -10, -7, -4, and then last but not least, -1. Okay, so if I wanted to plot these points, -2, -13 is off my graph, so I'm not going to worry about that one. -1, -10, I can plot that though, so on and so forth. Okay, I'm going to throw in another one. If I plug in 3, I get out 2. Okay, so then connect them using a nice straight line. Label my intercepts. So this is my y-intercept, which is right around, well, it is exactly 0, -7. And then my x-intercept, which is right here. Hey, once again, it's between 2 and 3. So again, I'm going to say about 2.40. This right here is an approximate answer. Okay? So that is how we graph linear functions using a table. We plug in numbers into a function and we see what we get out. In the next video, we'll dive more into this idea of intercepts and how those help us in word problems and how to graph.